So now we'll design a DFA ending with 1, okay, where the input alphabets are 0 and 1. So in such type of questions, what we have to do is, first of all, we'll identify the strings which will be accepted by this DFA. So the possible strings of length 1 are these, 2 are these, and 3 are these. So out of these strings, we have to select the strings which will be accepting this DFA. So the strings ending with 1 will be this. So these are the given strings which will be accepted by our DFA. Now what we have to do is, we have to decide the number of states which will be accepted by this DFA. So as we know that a DFA contains 5 tuples, and in these 5 tuples we have capital Q, Q0, QF, transition and your delta. So this is your initial state, this is your final state, and this is your total number of states. Now what we have to do is, how we have to decide the total number of states. The total number of states will be decided upon the minimum length of the string. So this is your minimum length string which is of length 1. So number of states will be 1 plus 1, that is minimum length string plus 1. So it will be 2. So the 2 states will be, first will be your initial state, let us represent it with Q0, and your initial state is always represented by arrow. As we have 2 states, so the other state will be your final state, that is Q1, and final state is represented by concentric circles. Now after this, what we have to do is, the minimum length string is 1, which we have to directly input on the initial state, and we have to reach to the final state. So 1 is accepted because it starts from the initial state and ends on the final state. Now if I talk about the strings which will be accepted by this DFA, will be those strings which will start from the initial state and end on the final state. Now for every state, what we have to do is, we have to make the transitions for these 2 input alphabets. So for this state, we'll have the input alphabet 0, 1, and similarly for this one. Now what we have done is, we have made the transition for Q0 for the input alphabet 1. So we are done with this. Now what we will do is, for the state Q1, we are going to make the transition for the input alphabet 1. Now we are focusing first of all on ones. Why? Because we have to design a DFA which will be ending with 1. So first of all, we'll focus only upon ones. Now what about this one? We can have 2 transitions for this. The one is, we can have a self loop here, or we can have a transition this way. Now we have to find out which one is correct. So let's first of all discuss this transition. And if I talk about this transition, what are the strings accepted by this transition? We start from the initial state, we reach to the final state, 1 is accepted. Now if I consider this self loop, and this self loop is optional, so we can take it any number of times. So if I start from your initial state 1, 1, so 2 ones are accepted, then 1, 2, 3, 3 ones are accepted, then similarly 1, 2, 3, 4, so 4 ones are accepted. In this way we can say that any number of ones will be accepted. Those can be odd number of ones or even number of ones. So it means it is accepting all possible combination of ones. Now if I take the transition this way, and if I remove this, what will be the strings accepted here? We have to start from the initial state and we have to reach to the final state. So 1 is accepted, then again 1, 2, 2 ones are accepted, but it is reaching on the non-final state. This is your non-final state and this is your final state. So these 2 ones are not accepted because it is ending on non-final state. So we'll again start from the initial state 1, 2, 3. So 3 ones are accepted because it is ending on the final state. Similarly 1, 2, 3, 4, 5. So 5 ones are accepted. Now if I see this pattern, this particular transition is accepting only odd number of ones, and this is accepting odd as well as even. It means all possibilities of ones. So we are going to prefer this particular transition. Why? Because it is accepting more number of ones. So this will be cancelled, or you can say removed. So we have justified the number of ones in both the states. Now we'll focus upon zeros. Now as there is no condition on 0, so we'll simply put a self loop of 0. So here we have put a self loop of 0, and again for this state also I am putting a self loop of 0. Now for this state I have made the transition for 0 and 1. Similarly for this state I have made the transition for this 0 and 1. Now what is this next step? What we will do is, We'll verify whether these strings are accepted by this DFA or not. Now pick up this first string 1. Starting from the initial state, reaching to the final state, 1 is accepted. Now coming to 0, 1. 0, 1. Starting from the initial state and reaching to the final state, 0, 1 is accepted. Now 1, 1, 1, 1, accepted. 0, 0, 1, 0, 0, 1, accepted. 0, 1, 1, 0, 1, 1, accepted. Then 1, 0, 1, 1, 0, 1, accepted. 1, 1, 1, 1, 1, 1, accepted. So it means all the possible strings which was to be accepted are accepted here. And if I talk about the strings which does not need to be accepted are 0 and 00, 10 and the remaining strings. So we have to also verify whether these strings are not accepted. So 0 starting from the initial state ending on the non-final state, it means 0 is not accepted. 00, 00 is also not accepted. 1, 0, 1, sorry, 1, 0. Now we had made a mistake here because what happens is, if I talk about this 0, it is ending with 0. So it means this transition is wrong. So we have to make the other way round and we'll make this transition this way. Now see, 1, 0, 1, 0 is not accepted. Now coming to 0, 0, 0, not accepted because it is ending on the non-final state. 0, 1, 0, 0, 1, 0. Again ending on the non-final state. 1, 0, 0, 1, 0, 0. And then 1, 1, 0, 1, 1, 0. So we have seen that those strings which needs to be accepted are accepted here and those strings which does not need to be accepted are not accepted here. Now just pick up a random string. Let's say 1, 1, 0, 0, 1, 0, 1. Now this string is ending with 1. So obviously it has to be accepted by this DFA and we will verify it. So it will be 1, 1, 0, 0, 1, 0, 1. So it is accepted. Now take a other string. Now it is ending with 0. So it should not be accepted. Let's see if it is being accepted or not. 1, 0, 0, 1, 1, 0. Which is ending on non-final state, it means it is not accepted. So we can say that this particular DFA is designed for all the strings which are ending with 1. Now if I have to make the transition table for this, what I have to do is, here we'll put the states which is represented by capital Q and here we'll say the input alphabets. So input alphabets are 0 and 1 and your states are Q0 and Q1. Q0 is your initial state, so it will be represented by your arrow, and this is your final state Q1 which will be represented by concentric circle, or you can also put a star which says that this is a final state. Now on Q0 when you input 0 it reaches to Q0, so Q0 on 0 reaches to Q0, Q0 on 1, Q0 on 1 reaches to Q1. So this will be the transition. Q1 for 0, Q1 for 0 reaches to Q0 and Q1 for 1 reaches to Q1. So this is the transition table for the given DFA. Similarly, if I have to show the processing of a string, what I can do is, if I take this particular example, what I'll do is, I'll start from the initial state Q0 and I'll input the string 1, 1, 0, 0, 1, 0, 1. Now this first particular bit will be input on Q0. On Q0 when I input 1, on Q0 when you input 1 you reach to Q1, or simply you can say on Q0 when you input 1 you reach to Q1. So the transition will be Q1 and we have processed this, so we are left with this. Now again on Q1 when I process 1, on Q1 when I process 1 it reaches to Q1. So again I am on state Q1, but I have processed this one, so I am left with 0, 0, 1, 0. Then again on this Q1 I have to process the 0. Q1 on 0 will reach to Q0. So it will be Q1 on 0 will reach to Q0. I have processed the 0 and I am left with 0, 1, 0. Again Q0 on 0. Q0 on 0 will reach to Q0. So it will be Q0 and I am left with only 1, 0. Again on Q0 when you process 1 we reach to Q1 and we are left with 0, and Q1 when on 0 reaches to Q0. So you have reached to Q0 and I have missed this one, so I have to write it here. again on Q0 when you process 1, so you reach to Q1, and this is your final state and this was your initial state. So we can say that this particular string is being accepted by the given DFA, and this procedure is called as the transition. And the delta symbol that we have used here, this delta symbol is representing your transition, that is the change in the given set of states. So this is the given DFA for the strings which are ending with 11.